So today we're going to solve Leetcode number 1481, least number of unique integers after k removals. So we have an array of integers, and it seems like they can be in any order, and they have some elements that repeat 5, 5, 4. So we want to find the least number of unique integers after removing exactly k elements. So if we remove one element, then only 5 is left. Output is 1, so there's only one unique integer. Here we have an array consisting of, I guess, a mix of unique integers and non-unique integers. We have 4, we have 3, we have some 1s, and then we have 2, and then these extra 3s right here. And so that means that there's 1, 2, 3, 4 unique integers. And we want to remove 3 elements. So if we remove 3 elements, we want to end up with the least number of unique integers. And saying here that we remove 4 because there's only one 4, then that's the most unique integer, and we want to remove that. There's no copies of 4 anywhere. And then we want to remove 2 more integers after that. And so that we can choose 1, we can choose 2, and we can choose 3. There's 2 1s, so we're going to have to remove 2 1s. And then there's 3 3s, so probably 3 would not be a good choice. Or we can remove 2, and then we will end up with only 1s and 3s left. We could also remove 2 1s, and then you will end up with basically 1 and 2 left. 3 and 2 left. So either one of those is the answer, but in general, since we're searching kind of for the most unique integers, we probably want to kind of remove the integers that occur the least number of times until we end up with something where we only have like integers that repeat a lot. So basically you want to remove the integers that don't repeat the least number of times, or the integers that have like the least count. And then you're going to be left with the integers that have like the most repetitions, and then you have like unique integers that way. So that case, I can think of one way to solve this, which would be first to go and count every single integer, right? And then after you count the integers, you want to basically have like a sorted hash map, and then like where one of the keys is the integer. Let's say in that second case is 1, and then next key is going to be the number of times that it appears. And so 1 appears twice. And the reason why I would say sorted is probably, if you're counting this, you want 4 and 1, and then 2 and 1, and then 3 and 2. Actually, that's 1 and 2, and then 3 and 3. So you probably want to have this like kind of like a min heap, I'd say. So after you have counted these, you want to kind of insert them some way. So maybe it's not terribly efficient, but you want to maybe store the integers into a hash map with the counts first. That will take us O of n. So loop through array and count all integers counts into a hash map. That's what I would probably do first. After we've generated this hash map, maybe we might want to convert hashmap into heap. And specifically, we probably want to use a min heap. And so we're going to be using like the key of the min heap to be the second element here, which is going to be the counts. Now, whether or not I can do that in Python, I'm not exactly certain. But if we can, then that's exactly what I want to do. So now I think after that, I want to pop k elements from the min heap. But I should rephrase this saying k times from the min heap, because an element can appear multiple times inside of the heap. Well, not multiple times, but it will appear once, but it might have like more than one count. So when we pop from heap, we might want to decrement the count. And then after we decrement the count, if count is greater than 0, then we reinsert into the heap. So I think we have a good framework now to start coding our solution, and let's just see how it goes along. So first we might want to have an counts hash map here, and then I'll actually make this a default dict so that if something isn't in here, then we can just increment it starting from 0. And so for, I guess, num in array, let's iterate through anything counts of the number plus equals 1. That's just your basic counting. After this, we want to convert this hash map into something like tuples, where we have each element first. So I remember in JavaScript that's object.entries. And I do want to look this up first, even though you might not be able to do that in an interview. But I don't remember, let's see, keys and values of a dictionary in Python. Waiting for our AI to load. Okay, we probably want to get the keys and values. We could do that actually with a comprehension, I think, but there's a faster way. It returns a view of all values, returns the keys. Items, there we go, items. So we just do items is kind of like object.entries in JavaScript. So we would do, I guess, counts.items for item in counts.items. Okay, this is probably not a very Pythonic way of doing this. We'll first do num count in counts.items. And then we eventually want to be heapifying this into something. So I'll say heap is equal to array. And then after this, we want to do heap q.heap push our item, or well, the heap is actually heap. And then we want to push the num and the count. But here's the thing. We want to sort this by the counts left. And so there's two things we want to do. Can a heap contain duplicates? Is one of the things. And yes, they can. But I'm specifically looking in Python if the min heap can contain duplicates. Okay. Duplicate keys, but no duplicate elements. Heap queues. There's probably a better way to do this, but if I just reverse this now with the count and the num, then you can store it this way. So that's actually the heapification. I know it's a little bit inefficient way to heapify. We could have heapified by just heapifying by using like a key, actually. But since it's already coded out, I'm not going to change course here. And so now we want to pop k times. So this one, I can say for I equals 0. Oh, wait, we're in Python here. So I in range of k. So range k, let's just check that real quick. If k equals 2, then range k is going to make 0 and 1. So that will go 2 times like we need it. Okay, so now we're doing the part where we pop k times. Each time we pop from the heap, we have to decrement count. And if count is greater than 0, read insert into heap. So we have now, we're going to be destructuring count. Num is equal to heap q dot heap pop. We want to insert our heap, and we don't need any other argument. And then now we have the count and number. So if count is greater than 0, we want to make it greater than 0. We don't want to reinsert. So if count is greater than 1, because if the count is going to be 1 and we're going to decrement it, then we're going to end up with count 0, and we don't want to reinsert that. So we should write down if count is greater than 1. And since count now is greater than 1, we have to do count minus equal 1. And then, yeah, so the smallest count will ever be is 1. And we have 1, then we want to reinsert that into the heap. So heap q dot heap push. And then we want to push that onto our heap. And then we'll be pushing the tuple count num. And count got decremented, so that's fine. Okay. So we run this k times. And then now we need to find the least number of unique integers after removing k elements. So basically now the heap will have kind of like the length of the heap. It will be the number of unique elements. All we have to do is return that. So we'll return length of heap. So going through this algorithm, let's say we want to do 554. No, wait, that's a little bit of a trivial case. So let's just walk through this example where k equals 3. And so when we go through here first, we'll just generate the counts. So obviously that's that. I think we generated that earlier. Let me copy it over. Up here, and I'm in Vim mode, so Leetcode doesn't let me copy. All right, so this is what we've generated. Then we turn this into a heap. And what we're doing when we're turning this into a heap is that we're pushing 4, 1. It's backwards. So it's going to be 1, 4. And that's comma. So remember, 4 is the number. Next, we're going to push 1, 2. And since these are equal, they're just going to remain at the top of the heap. It doesn't really matter what order they end up in. The next thing we push is going to be 2, 1. And actually, that will be kind of like next into the heap. So that's what we expect. And the next thing that we push is, oh god, this needs to be count 3, 3. So we have all these now. First thing we're going to do is that we're going to remove k times now. So we remove 1. That's going to be 1, 4. And then we decrement count. And actually, we're not decrementing count. We're just removing it. So now our heap looks like this. And then next, we're going to take out 1, 2. And then count is 1, so we're not reinserting it. And then our k was 3. So we're going to take out now, it's hard for me to read this, 2, 1. Okay. We're going to take out 2, 1. And then, since 2 is actually greater than 1, we're going to decrement that. It's going to be 1, 1. And then we're going to reinsert that into the heap. So now our heap becomes 1, 1. So that's after k equals 3 times. Next thing we want to check maybe is if k happened to equal 4, what would we do? So if k equals 4, we have 1, 1. We'd pop that off, and then we return, well, we'd have 3, 3, and then we return length of heap. That would be 4 times. So the number we would be returning would be 1. After the 3 times, what we would do is that we would count the length of the heap. In that case, that was 2. That would be returning 2. And so let's submit this. Although there are some edge cases that we had to worry about first before I submit. Because we're going through... No, actually, I think we're good. I'm thinking of meeting rooms. So let's go. All right, so we have the runtime accepted. Let's kind of think about our edge cases. I'm not looking here with my eyes, even though I'm mousing over there, but in a real interview, you're not going to be given the edge cases, so let's see. If we have 0 elements in this list, then yeah, this will never run. This will be, I guess, empty. There's no items. Range k. Okay, so right now we have to make sure that k is greater than or equal to number of items. And so, actually that should be less than equals. Then see, now that is actually one of the test cases here. I haven't looked at there yet, so hopefully I don't spoil the rest of it for myself. Another thing is numbers. Does it matter if the numbers are negative? No, it doesn't. And now we just peek over here. It does have some constraints, but I don't think it matters for our case. I think I'm ready to hit submit and see what happens. All right, so it's kind of didn't use the best runtime. Probably my heapification wasn't the best way to heapify. It might just, yeah, I think you might run into like an O(n) squared situation there with this kind of crappy way of heapifying. So I'm going to just look up how to heapify and then cut this video. And so after a bit of searching, this was a comprehension that I was talking about where we're just trying to convert our our dictionary into a heap. You see in the code here, I had this pushing each one by swapping around, by iterating through the items of the dictionary. This basically does the same thing, but it's list comprehension. I'm not actually sure if this is faster, but in general, I've heard list comprehensions are faster. Oh, I see. So what we're doing first is that we're creating the list. So this is O(n), and heapifying is also going to be O(n). I really don't think this is faster, but let's see. And it was not. One optimization, I'm not sure if this is faster. I don't believe it is, unless there's some compiler things going on under the hood, is to use counter instead of counting by creating a hash map. This will already generate the hash map for you. Let's see how much this improves. Barely any. And another optimization I think that might actually make a significant improvement if you notice, we don't really have to store the elements themselves, like the numbers. We actually just need to store the number of times that they appear. So one thing we can do is that instead of going for counts of items, we can go for the values only. And so we'll do count for C and counts.values, and then we heapify that, and we don't have to worry about like our custom whatever we're doing here. Next, we don't really destructure count. We just kind of had to just pop from it. Count is -1, yeah, and we're no longer storing the number as a tuple. So we'll do count, run this, see how it goes. I don't think it reduces the time complexity, but it does help with memory a little bit. And I think in Leetcode problems, you don't really have to get the best solution. I don't think there's any better time complexity than what we're doing, so now we're just doing small optimizations. Yeah, so that seems to be the thing that kind of made us not get to the optimal distribution. It was the adding of the tuples. It's probably a little bit expensive time and memory-wise, but I think you can see now how long that, I guess, took for solving it. Normally, I'll update the timestamps below sometime, but yeah, you can see we now have like kind of the optimal solution, and this is probably good for whatever you're trying to do. So hopefully I'll get to do some more problems for you guys. See you guys again some other day.